What's matter?
So matter is anything that has mass and takes up space.
Okay, is tree matter?
The tree is matter.
What about my coffee?
It's matter.
What about the grass? Does that matter?
That's matter too. Basically, everything you can see, touch, and feel is matter, and also things that you can't see, touch, or feel are matter, like air.
So basically any solid, liquid, or gas is matter?
Yes. Yep. Anything that has mass and takes up space.
So matter consists of three parts. We have liquid, which is the water inside this bottle, solids, which can be this battery, and gas, which is the air around us.
So there are things called ionic bonds. Ionic bonds occur when one atom steals electrons from another atom. There are also things called anions. Anions are negatively charged. There are also ions called cations. Cations are positively charged. There are different types of chemical bonds. There are covalent bonds, which have atoms that share electron pairs. So covalent bonds are nonpolar. They have equal sharing of electrons, so charged balance among atoms. They can share from 1 to 3 pairs, so that can be a single, a double, or triple bonds. And they have electronegativity. They can also have polar molecules, which is unequal sharing of electrons due to different electronegativities of the atoms involved. So there are things called hydrogen bonds, which are also considered weak bonds. So now we're going to discuss chemical reactions. So to start, there are chemical equations, and as you can see here, Nicole is going into further detail on that. There are also different types of chemical reactions. There are synthesis reactions, which are anabolic. There are decomposition reactions, which are catabolic. And there are exchange reactions, which are displacement reactions. There are also redox or oxidation reduction reactions. And in that, there's one molecule, an electron donor, which loses electrons to another molecule. The one that loses electrons is said to be oxidized, while the one that gains electrons is reduced. There are also exergonic and endergonic reactions.
So right here we have the pH scale with acidic being 0 and basic being 14. As you can see up here, 0 is going to be hydrochloric acid. For 1, you're going to have battery acid. For 2, you're going to have lemon juice. For 3, wine. For 5, black coffee. For 6, milk. 7, blood or water. 8, egg whites. 9 can be baking soda or household bleach. 13.5 can be oven cleaner, and 14 is sodium hydroxide. And that's the pH scale.
Atoms are made up of protons, neutrons, and electrons. Protons are positively charged, neutrons have no charge, and electrons are negatively charged. So those three particles make up an atom. The center is made up of protons and neutrons. Let me draw that here. Surrounding the center of the atom, they're made up of electrons.
don't know. I didn't see them. I don't know what they're doing. Maybe training exercise.
These are
They're actually
layers of the electrons that float around the atom and are negatively charged.
Like I think someone shot at a cop. Yeah. It's all on the news.
The amount of electrons in an atom is equal to the amount of protons.
Yeah, when we had the homecoming thing, they were buzzing all around this area of Chopper.
This atom has 4 protons and 4 electrons.
Take care, though.
That's weird. Yeah. See you later.
So today I'm going to be discussing organic compounds. All organic compounds contain carbon. So the first organic compound I'm going to be discussing is carbohydrates. So this bread, lovely bread, is an example of carbohydrates. So in carbohydrates, there's a ratio of 2 to 1 of hydrogen and oxygen. So that would be 2 hydrogen to every oxygen. So it consists of carbon, hydrogen, and oxygen. So they can exist in monosaccharides, disaccharides, and the disaccharides are made through a dehydration synthesis process, and then also polysaccharides. So the next organic compound I'm going to discuss are lipids. So lipids are neutral fats. So when they're solid at room temperature, they're considered fats, and oils are the ones that are liquid at room temperature, but they're also fats, or lipids, excuse me. So they are formed through saturation of bonds. They're made up of fatty acids hooked to a glycerol backbone by dehydration reaction. So there are 3 different types. There's monoglycerides, diglycerides, and triglycerides. So there's phospholipids. Those are cell membranes, which is formed with the phospholipid bilayer. There's in that glycerol 2FA and phosphorus containing group. So FAs are nonpolar, and the P group is polar. And then there are steroids. Example of steroids would be cholesterol. So to discuss inorganic compounds, as we've just discussed organic compounds, so I'm going to discuss the properties of H2O or water. So the 2 characteristics that most affect its properties are that water can be polar and that it can form hydrogen bonds or H bonds. It's also known as a universal solvent. Many of you may have heard that already. So it consists and forms hydration layers. So the layers of H2O molecules around large charged molecules, thus shielding them from other charged molecules. This forms biological colloids such as CSF, which is cerebral spinal fluid. They serve as transport medium for the body and reactant in many chemical reactions. Water does not mix with nonpolar substances. It has a very high heat capacity, very high specific heat capacity, and high heat of vaporization, the energy required to convert liquid H2O into steam, in other words, and cushions organs from physical trauma. So now I'm going to discuss the levels of structure of proteins. So there is the primary structure, the secondary or alpha helix or beta pleated sheet. There's a tertiary, quaternary, and those are the levels of structure of proteins.
Globular proteins are proteins with a specific job. Enzymes are proteins that speed up a reaction. Proteins also help transport ions across the cell membrane. And they also regulate pH by serving as buffers in the blood. They also form antibodies in the immune system for defense. and provide as molecular chaperones and regulate metabolism.